Hi, this is for Algebra, Module 2, Lesson 7, Radical Ideas. So in this one, we are practicing our rules with exponents and radicals. Radicals would be roots. So uh, we have two gals, Tia and Tahani, and up here, we're just reminded that what we talked about in Lesson 4, the m in an exponent is the same thing. Sorry, the numerator in a fraction exponent is the same thing as the power of a root, and the denominator, the n in this case, is the same thing as the root when we put it in radical form. So this first one, sorry, my screen keeps shaking around here. This first one is exponential form. The second one is what we call radical form. So we've worked with the rules for the radical form these last couple of lessons. So if you have, say, the third power to a cubed root, that brings us back to our original number. If you have two numbers together, or a number that can be factored out into two numbers, so say like 27, we could split it into 3 times 9 and then take the roots of the 3 and the roots of the 9 and then be able to multiply them that way. You can do the same thing with division. So that's the new one. This one here is the new one for what we're learning. The other two we have done before and split them up in previous lessons. So that's Tia's way of doing it. Tahani says she likes the exponential way. And these are all rules you should have learned last year. And we've been reviewing them and practicing them a little bit. So this is kind of your cheat sheet for what the various rules are. I would keep track of this paper, or I have it as a document as notes as well in Classroom. So if we scroll down, now we're going to practice this. So we've got 4 problems that we are going to try both ways. Basically, what this lesson is trying to have you do is practice both methods and see if there's one you like better than another. So Tia keeps it in exponential form. Sorry, my words mixed up. Radical form. Keeps it in radical form and splits up the numbers underneath it to get them to cancel out. So notice that on here, she's took x to the 8th, and because it's a third root, she split them into thirds. So how many x to the thirds can I get out of 8? Well, I can get 1 set of 3, 2 sets of 3, and I'm left with 2 left over. And so knowing this, I can cancel out my 3's and just leave an x. These 3's will cancel out, leaving me just an x. That's how we get these 2 x's over here. I only have 2 x's in this one, and so I don't have enough to cancel out that root, so we just leave this the same. And so our final answer is x squared, because that's x times x, and then times the cubed root of x squared, because that's what our leftover is. Tahani, though, she's going to take it and put it into a fraction. So we said that the exponent is the numerator and the root is the denominator of our fraction. And so when she does that, she has x to the 8 thirds. Well, 8 thirds is an improper fraction. So now we take it and split it up into 2 and 2 thirds. And just like we know with our exponential rules, if those two numbers are added together, we can split them apart and make 2 separate numbers, giving us x squared and x to the 2 thirds. You could leave it as that, but a better final form in this case, because we still have, we don't usually keep exponents as fractions. It's best to put it back into radical form. So we have our x squared, just like we had up here, but this time the 2 thirds, again, my 2 is my exponent, my 3 is my root, and I put them back that way. So let's try it. Let's try with the first one. This one, these two will seem similar to what you've done previously in lesson 5. So Tia says, let's keep it in roots. So I'm going to use, let's use blue for her. So 27, I want squared roots. So the first thing you want to do is think 2 squared is 4, 3 squared is 9, 4 squared is 16. Which of 4, 9, and 16 goes into 27 evenly? Well, 9 does. So I'm going to go ahead and split this into the square root of 9 times, 9 times what gets me 27? 9 times 3. And I'm going to split them up this way. Well, I know the answer to 9 times the square root of 9. Square root of 9 is 3. But I cannot simplify the square root of 3 anymore. It's not a whole number. So I leave it as square root of 3. So my final answer would be 3 square root of 3. So let's look at Tahani's method. Go ahead and make that circle a little better and out of the way. Okay. So Tahani says, let's put it into a fraction. So this one, I used pink. So 27 to the 1/2 power, because I have 1 as my exponent. There's only 127, and it's a square root, so that's a half. Well, I need to split 27 into its factors, one of its prime factorization. So I usually start with 2 and 3 because those numbers, we kind of know if they go into ones easier than other ones. And they're the basic prime numbers that are in most numbers. So 2 does not go into 27 evenly, but 3 does. So I know that I have a 3 times 9. Well, 9 can be split up more into 3 times 3 times 3. So this is 3 cubed, a 3 times, to the 1/2. So 27 is equivalent to 3 cubed. And I'm leaving my 1/2 as my exponent. Well, I know that when I have a power of a power, I multiply the two together. So that puts it 3 to the 3/2, which is the same as 3 to the 1st times 3 to the 1/2. And I'm running out of room. And that puts me at 3 to the 1st is 3. 3 to the 1/2 would be the square root of, not 2, square root of 3. So Tahani's, I feel, is a little more complicated when we have just numbers, but it still works. Scoot that back over so you can say, so it's 3 square root of 3. Notice we got the same answer for Tahani and Tia. So let's try a cubed root one. Do our square root method. Cubed root of 32. Well, before I can do my cubed roots, I need to figure out what are some cubed numbers. So 2 to the 3rd is 8. 3 to the 3rd is 27. 4 to the 3rd is 64. So which of these goes into 32 evenly? 8 does. So I'm going to go ahead and put the cubed root of 8 times, 8 times 4 is 32. So I'm going to split those two up. I have a cubed root of 8. We just said that was 2. But I cannot find a cubed root of 4 that's in whole number. So 2 cubed root of 4. Nothing else to simplify, so that's my answer, 2 cubed root of 4. Let's go ahead and circle those. All right, so Tahani, let's put this into a fraction. we have 32. 1 is my exponent. 3 is my root. So it's a 1/3. It's a really bad 3. 1/3 power. Well, 32 we need to put into prime factorization. Well, 2 goes into it one time, 2 times 16. And I'm going to simplify this, but I don't run out as I'm going to run out of room before I'm done. 2, if I keep multiplying my 2's together, I end up getting 2 to the 5th. So 2 times itself, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So I need 5 2's to get to 32, and I want that to the 1/3 power. Multiply those together, those exponents, 2 to the 5/3. Okay, I can split that up. My improper fraction turns into 2 to the 1st times, what do I have left over? 2/3. So 1 2/3 is the same thing as 5/3. So I have 2 to the 1st power, which is 2, times 2 to the 2nd power, because that's my exponent up. Nope, wrong color. 2's my numerator. And then I'm going to put it to the 3rd root, because 3 is my denominator. And that's my final answer. 2 times cubed root of 2 squared. Oh, wait a moment. Let's delete that one. We know what 2 squared is. 2 squared is 4. So it's 2 times the cubed root of 4. Now it matches Tia's up here. Go ahead and circle this one over here. So every time you do this, I'm going to scroll out here a moment. This one, this Tia's method should match Tia's answer. They're both answers should match. So when I looked at this one and saw it was a square root of 4, I realized I had to take this 2 squared and simplify it to a 4. And so that would be the simplest form then. Okay, let's throw in some variables since we're algebra focused. Okay, so now we have square root of 20 times x to the 7th. So let's do Tia's method first. We're going to do these as roots. So I'm going to first split up the 20 and the x. So square root of 20 times the square root of x to the 7th. Now let's split them up. So 20. Again, I have to think of my squareds. 2 squared, 3 squared. I just start with these guys. So 4, 9, 16. Which one works? 4 goes into 20 evenly. So I'm going to change this into the square root of 4. 4 times 5 is 20. And now I'm going to split up my x's into sets of 2, because sets of 2 will cancel out. So x squared, that leaves me with 5 left. So x squared, that's 4 total. Oh, I don't want any equals yet. If I do another 2, that's 6. Sorry, 2. Now I'm left with 1x left over. So with all of these, I now want to simplify what I can. Well, 4 square root of 4. My colors here. Sorry about that. The square root of 4 is actually 2. X squared, square root of x squared gives me an x. Square root of x squared gives me an x. Square root of x squared gives me an x. So all of those I did in orange can be simplified, but the ones I left alone can't. So if I put them all together, I have 2 whole. I have 3 x's, so that's x cubed, times, what do I still have in square roots? A 5 and an x. So I can turn that into square root of 5x. So I take the 3 I have on top, 3 x's, x cubed, 2, those all go in the front because we were able to simplify them without the square root. But the square root of 5 and the square root of x did not, so they stay inside. So this is my final answer. Let me get rid of my green there. This is my final answer for the square root of 20x to the 7th power. So it's honey. I'm going to go a little quicker on hers in the sense of let's find the prime factorization of 20 right away. So I want to do 2 goes into 20 twice because 2 squared is 4 and it's 4 times 5. So the prime factorization of 20 is 2 squared times 5. And then I have times x to the 7th, all of them to the half power because it's the squared root. So I went ahead and split up the 20 into its prime factorization. So just always double check. 2 times 2 is 4 times 5 is 20. They do match. Make sure this guy and this guy match before you move on too far. And then I left the x alone for right now. So now let's split them up. If I have 2 squared to the half times 5 to the half times x to the 7 halves, you know what? I might actually just simplify this one right here, right away. I can't get that one to erase. There we go. 2 halves, because 2 squared times a half is 2 2s, 2 halves. And so now I've got all these guys written out there. So what can I simplify? Well, 2 to the 2 over 2, that actually simplifies to 2 to the first, doesn't it? X to the 7 halves, I can actually split that up into 2 goes into 7 3 times with 1/2 left over. So it's 3 plus 1/2. So let's go ahead and put those over here. So now I have 2 to the first times 5 to the half times x to the third times x to the half. So just like in the one above, I want to take all the ones with the whole exponents. These guys have whole number exponents. I want to put them first. So 2 to the first is 2. X to the third stays the same. Now 5 and 5 to the half and x to the half, both are half, which is the same thing as a square root. They're both going to go under the square root sign. And notice my answer matches with Tia's up here on the top. 2x to the third times 5x square root of 5x, 2x to the third times square root of 5x. One more. This guy is a little more complicated. I might have to go down into the next below Tahani's to finish this one off. So let's simplify this one first. Well, let's do our roots. Let me find my blue here. So I want a cubed root. So 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. So which one of those goes into 16 evenly? 8 does. So let's go ahead and split up our 16, the cubed root of 16. So I'm going to do cubed root of 8. 8 times 2 is 16. So 8 times 2 is 16, cubed root of both of those. Now, my exponents. Let's simplify these x's first. I have x to the first on the top and x to the seventh on the bottom. When you're dividing bases, you subtract exponents. So it'd be x to the 1 minus, there, 1 minus 7, which would be x to the negative 6. So I'm going to put up here cubed root of x to the negative 6. Now let's look at the y's. The y's are 5 and 2. So that would be y to the 5 minus 2, which is y to the third. So now I'm going to take times cubed root of y to the third. Nope, I should have put that more inside. Want that inside the... Technically, it doesn't matter because it's just the one exponent. All right, so now let's keep simplifying. Cubed root of 8 is actually 2. Can't simplify this one yet. Oh, I have 2 here. Well, how many 3's can I get out of 6? Well, I can get 2, but it's negative 6. So I'm going to put x to the negative 2. Because if I have, this could be split into 3 plus 3, right? Those 3's cancel as well as those 3's and gives me a total of 2 x's in there. And when I'm doing this one, y cubed root of y to the third and the cubed cancel each other out, leaving me a y. So the only thing that's left at the moment in a root is the cubed root of 2. So let's go ahead and bring these over to the side. I've got a whole number 2. I've got a whole number x to the negative 2. And I've got a whole number y. The only thing that's left to put in the cubed root is the 2. Now, this is one way of writing it. Or, because we have that negative right here, negative means it goes in the denominator. So we could also write this, 2 valid answers, 2y cubed root of 2 over x squared. Either one of these works as an answer. All right, let's try Tahani's method. I'm going to go ahead and erase some of these guys, just so I can see my words again, my numbers again. Okay, so first step is to get my 16 into prime factorization. So if you remember what we said last time, we said that if we just keep multiplying by 2, we do get to 16. So 2 times 2 is 4, times 2 is 8, times 2 is 16. I needed 4 2's to get to 16. So cubed root of 2 to the 4th is the same thing as my 16. So I'm just going to make sure those two numbers match. Now I'm going to go look at my x's. I've already figured out over here that when I simplify my x's, I get x to the negative 6. I'm just going to go ahead and work with that. So I want the cubed root of x to the negative 6 times, same thing with the y. I already decided when I simplified those, it was y to the third, cube root of y to the third. So now I need to turn these all into fractions. So numerator is my exponent, denominator is my root. 2 to the 4 thirds times x to the negative 6 thirds times y to the 3 over 3. So also notice when I'm doing this, all of my denominators are the same. That should be something you helps you know that, oh, I must have done this right. I put the right ones in there. Because if all of my denominators are the same, then I'm still keeping it with the third root. All right, let's go ahead and split up what we've got. We have 2 to the 4 thirds is really the same thing as 2 to the first times 2 to the, if I divide that out, I end up with 1/3 left. X to the 6 thirds, those actually cancel to make it x to the negative 2. And the 3/3 cancel to make y to the first. My y's not. Oh. Come on. There we go. So I have y to the first. So I've split up those two. I'm going to go ahead and tack on my times x to the negative 2 times y to the first. And so to simplify this one, I can, I don't want to do that. I want to note that I have one fraction still in there, and the rest of these have whole number exponents. So all of my whole number exponents will go in front. 2 times x to the negative 2 times y. And then I want my cubed root of 2 to stay by itself. So here we ended up with the same thing we had up here. So we have the two options. Or I can change it back to a fraction and go 2y to the third cubed root of 2 over x squared. I'm running out of space. X squared. So either one of these gives me a final answer. Hopefully one of those works for you. Me personally, I like Tia's method when it comes to numbers, and I like Tahani's method when it comes to variables. So it just kind of depends on what numbers I'm working with to know which one I prefer. So there's all of them together.